So good morning. Welcome. I'm Stan Altman from the Mark. We are really fortunate to have, as today's presenter, Will Ross from IBM. Will has been involved with the competition from its very beginning roots when we started in 2014. In fact, one of the interesting things about Will is all the teams that win, Will is their mentor. So Will understands what's required. He's really good at giving you advice. I would pay very close attention to what he has to say. He's one of the most knowledgeable people about the competition and the way in which we've put it together. So without further ado, let me introduce Will Ross.
Thanks. I have a mic. I'm mic'd up. Thanks. So good morning. Can you guys hear me on the mic there? I just want to double check. Coming through? Great. So thanks, guys, for coming in. Did we switch this back over here to my presentation? Are you guys all sitting more or less with your teams right now? If you do have teams here. Does anyone here this morning not have a team yet? Just curious. Okay. Talk to Stan. He should, and you talk to Stan. I saw you in the back with a quick hand raise there. So like Stan said, my name is Will Ross. I work for the IBM Watson Group and have worked for the IBM Watson Group for about 4 years. So pretty much contemporaneous with when we started this competition. You guys can probably tell I'm not that far out of university, right? I came straight out of undergrad into the IBM Watson Group, had an amazing time and amazing timing in sort of joining that group. Started as a product manager, worked there for about 2 years in that area, and then moved into business development and M&A over the last 2 years. So I've been very focused on acquiring companies in the artificial intelligence space for about 2 years now. So what we're going to talk about a little bit today is the case statement. I want to talk largely about how we actually go through that process. I am going to spend a little bit of time at the beginning talking about what is the case statement in terms of the firm requirements of what it is we're going to do. I don't want to spend too much time on that. But instead what we're going to do is we're going to try and go through and answer a couple questions. So the first one is, how do you define and refine the problem you're trying to solve, right? How do you identify something that's both specific enough and big enough that it's actually worth doing for this competition? Then secondly, we're going to talk a little bit about how do you effectively conceive of and introduce a solution, right? So we think about a problem for a specific person or a group of people. How do we then take that and how do we translate that into something that we can actually go and do with cognitive technology? But as we'll talk about, it's about more than just cognitive technology. It's about more than just IBM Watson, using a variety of technologies and all the things that are available today. And then I think we've talked about in the past, even plausible technology that we think is going to be available in the very near future. How can we kind of solution out of that problem to think about what the potential is? And then third, and I think this is the part that scares a lot of people, we're going to talk a little bit about how do you take then that value that you're creating and start to translate that into some form of, you could call it a business case, right? That's where the case and the case statement comes from. A lot of the projects you're doing may involve public entities, so it could involve the City University of New York. It could involve New York City City Services. But the overall goal is to just say, how do you tie that back to some form of value for just generically any organization? I'll spend a little bit of time just kind of giving you guys my unsolicited advice on a few other pieces of this. So as a reminder, Stan talked about this briefly. What we're going to talk about today, I would say, applies to the case statement certainly, so that's the first milestone that's coming up. But I think the approach I'm going to take is really a lot more holistic. So as you think about the competition overall, a lot of this is going to come right back up by April 20th, right? So you're going to go through milestone number 1, then you're going to go into the boot camp. You're going to spend a lot of time at the boot camp focused on 2 things. One, Armin Pashkodian's going to come in and show you a lot of technical demos, get you a little deeper in how the technology actually works. And then 2, you're going to have a chance to actually pitch out your sort of pitch out your case statement in about a minute, right? So a 60-second pitch for the first time. But then you're going to go through all that, and then you're going to have to come back with a more in-depth business case. And all that really is going to represent is an evolution of what you're thinking. And so we'll talk about the importance of iteration. I think, how many of you were at the design thinking workshop? Right. I wasn't there, but I would imagine they talked a lot about iteration and the importance of coming back through. Yes, maybe, head nods, yeah. So we'll talk a lot about how that's going to kind of evolve throughout this. And my goal for today, like Stan said, I've been lucky enough to mentor, I guess, 5 teams total over the last 2 competitions, and some of them have done pretty well. So my goal is to try and give all of you the same advice that I gave them through those first 2 competitions, thinking very holistically about the thing with sort of a major on that case statement. So before I do, so like I said, we'll spend a little bit of time on the brass tacks. We're going to try and run through that really, really fast. And then because we've looked at, or I've worked directly with the 2 teams that won the last 2 competitions, what I thought we'd do today is we'll focus on the winners from those competitions, and we'll look at what was the process that they went through, because I can actually speak to that, right? I can talk a little bit about, this is what they were thinking about, this is the conversation we had, and then we'll take a couple pauses just for 5-10 minutes to give you guys a chance to sort of break at each section of this and talk about the different components. So, sorry, did someone have a question? No, I'm okay. So did want to get a sense of just who's here so I can kind of tailor this a little bit. In terms of majors, how many business or accounting or those sorts of majors do I have at least in the room? So less than a quarter. And how many computer science majors more or less in the room? Sorry? CIS, yeah, exactly. Information systems, whatever it might be. And then how many humanities majors? Anyone? No? I'm the only person who studied philosophy in this room? Okay. That's a little embarrassing. I did end up working in technology and in business, so highly encourage you to study anything you want to while you're in school, but that's all right too. In terms of past competitions, how many of you guys have done one of these case competitions before? No one. No one in the room? I think that's pretty typical, right? We found that more or less most people doing this are first-time competitors. So we'll spend a little extra time on sort of what a case statement should look like, brass tacks then. Prior workshops, who was in the design thinking workshop again? How many people? Okay, so most of the same crew here. And then, so progress so far, how many of you have actually defined sort of the problem you want to work on at this point? It's okay if you haven't, honestly. If you define it the night before the first milestone or you change after the first milestone, absolutely okay. I think a lot of teams actually change after the boot camp once they really get deep into what they're working on. So, and then anyone who's nervous about the first milestone. Yeah, okay. Well, a lot of confidence in the room, so that's good. So what is this thing? So if we think about the case statement, at the end of the day, what is it? It's a Word document, right? It's 2 pages. It's like every paper you've written in university thus far. It's just that the contents are going to be a little different, right? But when I like to try and define it, I think of it as just a very narrative explanation of 3 questions. 1, what is the problem you're trying to solve? And we'll talk about there's big problems you're trying to solve, and then again, they're really, really narrow and specific problems you're going to solve. You're going to hear me say that big problem, little problem thing over and over again. I'll talk a little bit about something I call the bow tie. That's going to be a big theme today. How do you intend to solve it, right? So what is the solution you're going to bring forward? And we'll talk about how it's important to be able to summarize that very, very quickly, but also to be able to go into some level of detail that shows really at the end of the day that you've just done your homework and that you really understand how the people that are going to work with your technology work today and are going to work in the future. And then third, and this is probably the real killer, is why should I care, right? It's very, very easy to create technology in this world. I have startups kind of come in and pitch me all the time, right? And it's very easy to create technology that no one actually cares about what it's going to do. And so why should I care can mean a few things. It can mean the financial aspect of things, right? Why should I care? Because it's going to save me an organization a lot of money. It can mean the altruistic component of things because it's going to make me and other people around me feel good. It can mean not cost savings, but actually revenue gains for a business, or universities have revenue as well, program revenue, right? Am I going to be able to bring more money in? So in terms of what it actually looks like. And again, we're just going to nail through this really, really fast. But here's kind of my broad recommendation on how to break down the 2 pages. So, and we'll talk about this more and more. But the rough order sort of guide here is taking 2 pages. I'd break them up into sort of 6 sixths here, if you will. And on the first page, I'd start with a really macro problem statement, and we'll talk about kind of what I mean by that. And then I'd try and hit the solution overview very, very quickly, right? I think it's important that you hit what is this big picture problem I'm going to solve, and then what is this technology going to do to address that big picture problem. Then what I would do is I would drill much, much more deeply into the micro problem statement, right? So now, okay, I'm going to go and we'll give some examples in a second, but I'm going to go sort of solve world hunger or whatever it is, but very specifically, I'm going to start by focusing on world hunger by looking in Kenya at a very specific population and improving the way ugali, which is local food, gets distributed within that region, right? Then, solution detail, only once you focus down into that very micro sort of problem will you actually be able to solution, right? So when you think about solving world hunger, seems like a very hard problem to solve. Solving ugali distribution in a very specific village in Kenya, maybe not so hard to solve. From that, we'll talk about, okay, staying within that narrow focus, how do we create value, right? So I'd spend some time doing that. And then the real trick here is you've started with this macro problem statement, and then you kind of balloon out to everything else. So you drill down into a problem, then you solve that small problem, then you show how that small problem creates a certain level of value, right? And then you expand that value out. So the metaphor I like to draw here is a bow tie, or I guess I'm calling this the bow tie method now, right? We start very, very big, very, very broad, moving left to right across the screen here. We look at something very holistic. We focus for a long time, right? And if you think about it, a bow tie, what holds the whole thing together? It's that knot in the middle, right? So we're going to major on this very small piece here, and then we're going to expand way, way, way back out. So what have we seen in the past? We've seen probably 2 issues in terms of how people do case statements. One is they get this think big picture really, really well, and they get this, okay, if I could solve that, that's incredible picture really, really well, but they never get focused enough to actually really explain to me how they're going to solve it, right? And so you're sort of left at the end of the day going, okay, sounds great, but I don't believe you, or it's not clear to me that you could actually achieve this, right? Then we get the other problem, which is sometimes people focus way, 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 way too narrow. I think one year we had a submission for solving the problem of rats unwrapping Christmas presents or something along those lines. It was very, very odd as we were sort of looking at it, and you will see people get super focused and kind of forget the big picture. So it's really about the balance, and we'll talk about that. So last thing I'll say, and then we'll start diving into the examples from the past 2 competitions, are why are we having you do this exercise? So how many of you are interested in potentially being some form of entrepreneur in here? That's part of why you're here. So a couple, about half, a little less than half the room. So this is what startups do, just in and out, right? If you are a startup co-founder, you are able to deliver the 30-second version of this, the 1-minute version of this, the 5-minute version of this, the 20-minute version of this, the 60-minute version of this, and you can also talk about it ad nauseum for 4 hours, right? But it's all about how do you, if you listen to them, how do you very quickly frame this big picture thing, hook everyone, get them very interested? How do you drill down and convince them you're actually going to do it? Convince me that, okay, you understand this well enough that now you're actually going to create some value out of this. And then how are you going to show me that this is going to expand, right? When VCs or myself, when we look at investing in small startups, what we're looking for is this total addressable market opportunity, right? And so small companies are very used to saying, huge market, I'm going to convince you that I can do it by focusing on this very little piece, and then I'm going to expand out. Second thing, being concise is everything. Didn't have that many humanities majors in the world, but you've all probably written at least a couple papers while you're in school. I would say, at least for me, I was a philosophy major, but most of my undergraduate was spent figuring out how to fill pages, right? It was how do I fill 10 pages? How do I reach 5 pages worth of writing? The second you sort of step out of school and into the real world, right, it's going to be the opposite. It's how can I take 40 pages worth of thinking and something I could talk, again, ad nauseum about, and condense it down into 5 minutes, 10 minutes, 1 minute, 30 seconds. And so that's a really important skill. And so this 2-page case statement at the beginning, as well as even the 3-page business case analysis, that's not very long. That's going to teach you how to get really, really concise. So that's a super important skill and a very practical skill that I hope you'll take with you out of this. And then third, I mean, this is just way harder than it looks. And when I say it's harder than it looks, I mean going through the bow tie. It's very easy to get caught up in the big picture. Again, it's very easy to identify the big picture, but then get so narrow and so focused that you get lost and you lose sight of everything that's out there. And the balance of being able to communicate both of those things in a way that all sort of sticks together, makes sense, is very, very valuable. So I threw Shark Tank up on the board here just because I think if you're ever curious about sort of where can you see just a lot of examples of this in the real world, Shark Tank's a great example. The conference room on the 7th floor of Astor Place where I work not too far from here is actually called the Shark Tank for just this reason. If you look at those pitches, what do they always do? They come to the front of the room and they say, I'm asking for X amount of money in my company that's going to solve this problem. They talk about a big macro statement. Then they back up out of it and they say, let me tell you a little bit about the history of my company, what we've done specifically, where we're focused right now. They get into that micro problem, right? And then by the end of it, it's usually some sort of pitch with a fist pump in the air, right? Something that, again, blows it up to the big picture, right? So if you're ever sort of lost, go watch some Shark Tank videos on YouTube, something like that. Those are very short pitches. I think they're 3-4 minutes at most. But what they'll give you is a really good sense of how to pitch things out in a pretty efficient way. So let me just stop there. I kind of went through the base requirements of a 2-pager, the little pieces. Any questions in the room before we kind of get going through the actual examples of how to do some of this stuff? Anyone? All right, didn't think so. Cool. So Stan, are there things posted online about the 2 winning projects thus far?
Yeah, we've actually posted the case statement for 10 projects that were 5 from 2014, 5 including the winning teams from 2017.
Excellent. So what Stan just said in the room here is online, if you go onto the Baruch blog and the CUNY Watson competition website, you should be able to find a bunch of examples of these case statements, right? I think what you're going to see is a huge amount of variety between them. You're not going to see that every case statement spends a third a page, 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 a third a page. By no means am I trying to bucket you into that or make you feel compelled to write them in that way. I think it's really important to include your own style, but I do think it's worth getting that. And so what we're going to do today is we're going to focus on 2 of those. I guess it sounds like Watson DCS from the 2017 competition is going to be one of those case statements that is up there. They did a very, very good job. And then we're going to focus on Watson LMSW. So Watson LMSW, they won in 2014. And their focus was on ACS, so Children's Services. Their end user, which we'll talk about in a bit, and some of you who went to the Design Thinking Workshop are probably familiar with end user by now, right? Was a social worker. And then in Watson DCS, what they were focused on was disease classification within Health and Human Services. So all the different disease reports come out from, think about anytime you get a blood test or anything like that, the result of that blood test is actually anonymously sent to a central body within New York City. So that if a bunch of people are testing positive for something like Salmonella or Legionnaire's disease, they can actually start to see that epidemic forming much earlier on and track that. And so they came up with a very specific solution that focused on how to classify those disease reports. So the reason we're going to pick these 2 is not just because they won. The other thing I'll say is they have very, very different styles, and you're going to see that kind of throughout this process as we go through. So the Watson LMSW team was 3 girls from Queens College. They had, I believe, a accounting major, a biology major, and a psychology major, women's studies major, who is now in graduate school for biology, I think. No, what is she in graduate school for?
Social work school.
She's a social work graduate student at Columbia, right? Yeah, so the three of them, they didn't have a very technical background, right? They had a little bit of business experience within their team, but they really didn't have the technical chops to go out and build a working prototype. You'll see a lot of that evidence in the way they framed their problem, right? They were probably more on the macro side than the micro side because they weren't trained engineers. They didn't know how to get necessarily into the deeper part of the problem, but they still won the competition. And so you'll see that kind of approach is probably an okay path, right? And then on the other side here, if I think about the Watson DCS team, 3 of the 4 gentlemen on that team were, I believe, CIS majors from Brooklyn College. And then the 4th member of their team was an accounting major. So they had a little bit of that business skill, but a lot of technical skill. And so you'll see as we go through, the Watson LMSW team, they didn't build a working prototype, but they had some design skills. And so they'd drawn some very nice versions of what could it look like. Whereas the DCS team, they were very technically skilled. They did build a working prototype, and it was on a very specific function, and it had higher accuracy than the system that New York Health and Human Services has today. But did it look pretty or anything like that? No, right? So point being, you'll see it in the way those case statements are written and the narratives. You'll see it in the way the presentations are formed. You'll see it in whether or not people build prototypes. But there are just a lot of different ways to assemble your team. And I really encourage you to play to your strengths and not think that, oh, if I don't have a prototype, I should just drop out now because you're not going to be able to win, et cetera. So what's sort of step 1 of this whole process? So I think one of the things I see more than anything else as people are starting to try and define the problem they want to solve is they look at a bunch of prompts, et cetera, and then they try and take the prompts, they try and take the knowledge that they have already about that prompt, they pick the prompt they know the most about, typically, right? And then they sort of just shoot from the hip and go out and write. I mean, you guys know how to do background research at this point, right? But one of the biggest things I'll tell you is that it's a different type of research in building out some of these case statements. What you're really going to want to be able to do is establish pretty instant credibility with any audience you have. And so there are a couple different approaches to doing this, and I'll sort of compare and contrast the 2 ways both of these groups went through this, right? And this was really step 1 for them. So Watson LMSW, they did gravitate towards the Administration for Children's Services because one of the participants in the competition had some family ties to Children's Services in New York and felt a personal connection to that. So do I actually within Los Angeles. So that was how we ended up paired together from a mentor perspective. And then what they did was they went very deep from a sort of desktop research perspective, right? So there's a lot of information posted by Children's Services about, they do a lot of internal studies on success rates, et cetera. And so you can see I actually lifted some of these statements directly from their case statement, from their 2-page case statement on the first page. So nationally, child welfare workers have an average caseload that often exceeds recommended levels by more than double, right? That sort of credibility and being able to insert that right into the first page of your case statement, when we talk about this bow tie, right? Where are we in the bow tie right now? We're in that first part of the bow tie. We're thinking about, okay, what is this big problem I'm trying to solve and how can I establish some credibility with it? Second statistic they listed. Specifically, the New York Office of Children and Family Services indicated that from 2008 to 2009, 73% of their reviewed child fatalities had a prior Child Protective Services report and implied maltreatment assessment, right? So this is a very real problem. They're establishing that credibility right before, and the way they've based these statements are very factual, right? These are desktop facts. One of the things you'll find is not every case statement or every case that you've been presented with is going to have this sort of background, right? Not everything's going to be something you can research via desktop. So Health and Human Services is a great example of this. These guys were really interested in the disease classification kind of process, and this was, I believe, one of the prompts that was given to them. I don't think anyone else in the competition even picked it. But they sort of looked at it and went, there's no information about how this actually works out there, right? And so They took a very different approach from LMSW. What they said they were going to do was, okay, we're going to find a mentor from within Health and Human Services. We're going to get on the phone with them for an hour, and then we're going to ask that person if we can get on the phone with someone else for an hour, and then we're going to ask that person for 2 more people we can get on the phone with for an hour. And they just went and they talked and talked and talked to a lot of people. And so what you'll see is if you're traditionally writing a paper, right, you want a lot of fact-based statements like the ones on the left. And if you look at the ones on the right, they're a little different, right? So New York City's Department of Health and Mental Hygiene receives thousands of electronic disease reports daily. It doesn't say on average between 2013 and 2015, they received 102,763 reports per day or something like that. But they had established enough credibility in talking to this audience that I think that's still okay. And they were still speaking with a certain level of conviction. The key here is eventually within this competition, you're going to be presenting to a very knowledgeable audience, likely, on the topic you have. I believe ACS, both of these teams actually went to ACS and HHS respectively and presented their winning solutions. So I encourage you to just sort of make sure that you've done enough homework around that. And then the other piece they have here, right, is epidemiologists and research scientists turned out to be their end users, which is part of this background research process as well. At the DOH-MH need to be capable of quickly tracking all diseases within the city to conduct research, detect and control outbreaks, investigate cases, and conduct partner outreach in order to protect the welfare of the community, right? Not necessarily a statement that exists out there, it's not a statistic, et cetera. But if I asked you why do we classify diseases coming in from different areas of the world today, you probably couldn't have drawn that conclusion without going out and having those sort of firsthand conversations. So second piece of this, so those are 2 really big problems, right? First, is it sort of clear what problems each of them are going after? On the one hand, you've got these overwhelmed social workers, right, without enough time. And it's really quick, right? Just those 2 sentences I lifted, there was a whole paragraph around them. You understand, okay, this is a big problem. It's a problem I should probably care about. It's a problem that exists in New York City. It's a problem that probably exists outside of New York City. Right, and then you've got it. It's very sort of quick to get there if you do the research to establish credibility. Where you see people spending too much time is actually where they haven't done the research to be able to get down to it really, really quickly. So then the second piece of this is about how do we drill down, right? So how do we first take that step to getting towards the middle of the bow tie? And I think this is probably the most underappreciated and most difficult piece of the skill. And it's actually typically derived from the research that you're doing originally, right? But what you want to do is you want to try and identify a person or a group that effectively is going to say to you, or you can read between the lines if you're just doing desktop research, right? But effectively what they're going to say to you is, if I could just, right? If I could just do this thing, then this problem would be solved and I could do my job that much better, right? Or this many more people would have a better outcome. So let's talk a little bit about how each of these teams drilled down, right? For LMSW, it was about, so hundreds of cases are being handled by almost every caseworker, right? They had that statistic, they knew that that was happening. And so the logic they kind of went through was they said, all right, a critical step in any case is understanding kind of all that's happened in the past, right? There was a lot of information about the IT systems that they'd installed in the past and how they were trying to organize all this information, because when a caseworker comes in, what's the first thing they do? They get handed a file about this big or sometimes about this big. I think, oftentimes it's a multi-child household, so it's a stack of files all that big, right? And they have to try and go through all of that information. Sometimes it's in paper, but some of it's on a computer. It's all in disparate systems. And so what they eventually got down to was, okay, well, so what is the type of problem I want to solve here, right? Am I going to be able to make a social worker a better caseworker? Maybe not. Am I going to give them better sort of spider senses of what might be going on in a home, whether or not there might be signs of maltreatment around them? Probably not, right? I'm not going to do a use case where I've got a little camera mounted to their head and it's looking for visual cues around the home, right? That's not really a part of the job I can make them better at. But what could I potentially make them better at? It was enough of an issue in all of these cases, they felt, that to just organize all of this information in a dashboard that would help sort of condense all that information down. And also you'll see as we get into their wireframes, show sort of a timeline or a lineage of how all this happened. If I could just do that for a social worker, I could free up all sorts of time for them to actually spend the time in home and make these better decisions. And that would be worth doing. In the case of DCS, so like I said, thousands of electronic disease reports coming in. I think they eventually did get to an average number, but it's absurd. During the final competition last year, they actually rolled out a scroll with the average of a daily worth of reports, and it went from sort of this side of the room to that side of the room in size 8 font, right? So huge amount of disease reports, and people, this is what one person has to go through in a day to manually classify, right? And these are like PhDs, right? They're epidemiologists. These are people who are very, very skilled labor, and what they're doing is they're going through and just classifying. If that's 3 hours of your 8-hour day and you spent 7 years getting your PhD in epidemiology, you can imagine how that sort of burns you out, right? So what they realized was the first step to any analysis they did, right, predicting a Salmonella outbreak, we can all agree that was important. Predicting the Legionnaires outbreak that happened in New York City a few years ago was the one they focused on. The first step to any of that ever happening is this classification of all these diseases. It's a choke point, right? There are all these amazing things we can do once these diseases are correctly classified. But today, someone manually has to go through and classify those, right? And all of that, right, it's done by hand, and it's done by these researchers. It's not being outsourced. It's not being given to a different type of labor. It's literally those researchers who have to go through and do it. And if you looked at what an example was, it's not overly complex, but it's incredibly hard for computers historically to have understood, right? Because it's just a natural language tag. None of them look the same. That says something like herpes zoster negative, salmonella positive, something else, right? And so they came down to this statement, which is, if I could just prevent time from being spent on mundane classification tasks, we could save people so much time and potentially prevent a future outbreak, right? Which we'll talk about for them. Part of the value for them was not just about saving time, right? It wasn't about less people doing this so we don't have to spend as much money on people doing this. It was, no, let's spend the same amount of time doing this. We're just going to spend less time on classification, more time on analysis. What if we prevented just one outbreak a year? What would that potentially be worth, right? So the other piece of this, as you sort of focus down onto the narrow piece, is defining who the end user actually is going to be, right? So we talked about in these big macro problems, it's very simple to sort of lose track of, okay, what am I actually solving, right? And I want to make a statement that's a bit of a bold statement. And that is that organizations don't have problems. Businesses don't have problems. People have problems. Within any organization, within any business, if you think about an issue that's systemic across that, you will ultimately be able to boil it down to a person who has an issue, whose life could be made easier, or a group of people, often a group of people, and if you could make that issue easier for that person, then you could solve that big problem, right? And so as you think about coming down into the bow tie, one of the things that's really important to do is to try and learn who that person is, right? Go on LinkedIn, go on job boards. What is their job description? What is it that they actually are expected to do? Do firsthand research, speak to the people who do this, right? Try and understand what it is they do, why they can't do it as well as they would like, and then try and draw that connection back up into the bigger problem. Try and avoid situations where, oh, it's this group of people focusing on this task. If that's true and if that's what you hear, okay, try and break it down. Who does what part of the task, right? How does this map back and forth between them? Sometimes you end up with these very complex webs and it's not a simple, line workflow for a single person. But eventually what you'll find are these choke points, right? Like the DCS team we talked about. If all I can do is classify diseases a little better, then the epidemiologist can go and do their analysis, right? And so when we think about the end user is the person who actually uses the technology. That's the other piece of this. They're not necessarily the person who benefits, right? if you think about the social workers, they benefit in some way, right? They spend less time working on foraging for information and organizing information, but the ultimate beneficiary, probably, right, is the children that they're taking care of. And within DCS, it's the population ultimately that's the beneficiary. So you want to separate that out and again get into whose issue is it, right? In this case, it's the social worker. And what was their issue? The social worker is presented with all these files. They can't organize any of that information. That means they don't have enough time to spend actually doing this thing. So what is it we're going to solve for that individual? We're going to try and help them organize that information. We're going to present them with some sort of dashboard or something like that that's going to make that much easier for them. And then for DCS, who was the end user, it turned out to be, and this was a bit of a revelation for the guys, honestly, it turned out to be epidemiologists and research scientists, right? Again, almost all of them have PhDs, 7 years of education, and 3 hours of an 8-hour workday, or I think 3.5 hours of an 8-hour workday, spent just going through, classifying individual lines of diseases, plain files of text. Just think, going through Excel line after Excel line. If I can just eliminate that, what can I free up? What can I do, right? And who's going to use it? Well, today they're the person who gets the data and then puts it into an Excel sheet and goes through it. So why wouldn't they just drag and drop it into my Watson classifier and then they get the output? So they're the end user, right? So what's the output of this piece of the process? So we've talked about kind of this initial funnel in, right? That left side of the bow tie. How do we start big? How do we go do our background research? Then how do we identify sort of the if only I could do this statement? And then how do we identify the end user, right? The last thing I'll sort of say is a good check on this piece of the process is the ability to create what I'd call a who, what, wow statement. And did they talk about this in design thinking with you guys at all? Right. So for those of you who weren't in the room, this is a bit of repetition. This is sort of an IBM thing to talk about who, what, wow. But who? So who is your end user, right? What problem are you going to be able to solve? What is the solution you're going to be able to present, right? And then wow is actually getting back up into the big piece of the bow tie again, right? What's so incredible about this, right? Am I going to be able to do it in a millionth of the time, right? Am I going to be able to do it in 90% of the time, but it's going to be done that much better, right? What you'll find is the who, what, wow statements are not always perfect. I think they do a really good job in the design thinking workshop sometimes in writing a really pithy, nice who, what, wow statement of, you know, the Subway sandwich artist is going to be able to dispense the mayonnaise onto the sandwich in an eighth of the time and therefore be able to process 40 more customers, right? What you sort of see here, and again, you'll see the contrast in the teams here, is maybe a less clear set of statements. So I think LMSW played to their strengths here, right? They were much better at kind of defining this piece of the problem and phrasing it a certain way. But it's probably a broader problem if you think about it. That was ultimately their output. So social workers, with the support they need to effectively address child abuse and maltreatment cases more efficiently and accurately than ever before. So they're saying their solution is going to provide social workers. So you can see it's not quite a who, what, wow statement. You don't necessarily have to write it as a who, what, and wow as a single sentence. I think it's a great thing to do. But you can still see, what did they ultimately get to? They got to social workers are going to be able to effectively address child abuse more efficiently and accurately than ever before, right? Now, there's a lot of room for getting more specific there. And I think as we go through this, what you'll see is this team had a really excellent vision and a really broad vision, but just by nature of their training, they were a little less a set of engineers who drilled down onto this very specific thing, right? And so the possibility here was so great, and the way they articulated the value was so good that they were still able to win the competition. But I think where they had a lot of room for improvement was that getting very specific piece. And then if we think about Watson DCS, so who, and you can see, right, the way this is written, it doesn't really look like a who, what, wow statement, but it's in there, So an epidemiologist and research scientist will be able to classify or be enabled by classifying so that they can accomplish more in less time and handle an increased workload. So there's still a who, what, wow statement in there. And those of you who went through the design thinking workshop, and I'm happy to point any of you to sort of those resources because they're very publicly available. We'll see sort of some of the issues with how these statements are written and how they could be a little cleaner. But ultimately, it's a good check, right? Is no matter how you write the sentence, it doesn't have to go who, then what, then wow. It can be the wow, then the what, then the who. But can you look back at it and can you say, okay, who am I solving this problem for? Who? The individual, the end user, not the organization. Organizations don't have problems, right? What am I going to do for them very specifically, right? Do I understand their process well enough to really honestly reflect and tell myself, yes, this is what I will do for them that will actually fit into how they work today in their workflow. And then the wow, right? Have I lost track of those ends of the bow tie? Is there still this big picture implication of what I'm doing that can be very, very meaningful for them? So that's all I have for this piece of this. What I want to do is, just because you guys are probably sick of talking to me, and I think most of you are here with one or two of your team members, is spend a little bit of time just letting you guys all sort of talk and sort of think through this piece of the process. So again, like the left side of the bow tie down in. And then what we'll do is we'll start to focus in on those next two problems, right? Which is, okay, now you've got your problem statement. How do I define what that solution is? And then we'll eventually go into sort of what does the business case look like. So I'll give you sort of 5-10 minutes. I would encourage you to sort of talk about what's the most interesting thing you've learned about your project thus far. And if you don't have anything to talk about, that might be a good sign that you have a little more room to do in terms of background research, et cetera, right? Are there any small pieces of the puzzle that are really attractive to you, right? Have you narrowed down enough yet? Or is that something you need to go work on? And then can you identify an end user and come up with a who, what, wow statement? If you can write a who, what, wow statement right now, you're in a good spot. If you can't, that's okay too. And even if you can, like we said earlier, you may change this in like 2 days. So that's totally okay. So I'll give you guys 5-10 minutes, and then I'm happy to come around and sort of help whoever out. All right. So I talked to a couple teams about sort of their projects, and I'm happy to sort of stick around and talk to any of you. I'll write my email up on the board sort of towards the end of this. You'll all have individual mentors, and it'll be hard for me to be sort of a consistent mentor to all of you, but happy to sort of take questions as they come, et cetera. The things I sort of heard throughout there, couple areas. One person asked about the business case element of this and the cost savings and how do I calculate. We're going to get into all of that. It's sort of a latter part of the case statement. I think right now the focus has been on what's the problem we're going to solve. But the other piece I'd encourage you to do is back out of what you've just looked at. Some people showed me their early draft case statements. What I saw missing twice was who, right? Who's going to use this thing? At the end of the day, if it's a piece of software, if it's any app you have on your phone, right? Someone has to actually use it. Someone has to consume it. If that person doesn't exist today, then they have to exist. Or maybe that person exists today, but they do something different, right? Maybe they process a lot of inbound requests, right? And you want to enable them by looking at social media to do some sort of outbound request. Well, that's a job change for them, right? So does that mean the inbound requests are going to lessen because of your solution? If they don't, do you need to hire more people? Well, now you may actually have an increased cost, right? Now there could still be enough benefit to outweigh that, but you have to think about who is that person, right? If you're solving a problem out there in the world today, chances are someone's trying to solve it. They just aren't solving it well enough, right? As you want to try and figure out who's that person who's trying to solve it, right? And work through that. So just really quickly, and I know it's a competition, you might want to be proprietary. Anyone have a who, what, wow statement or feel sort of far along and want to just sort of game it out with everyone here? I'm okay if there are no volunteers because I'm competitive myself, so. Anyone? Any takers? No? All right, competitive bunch or nervous bunch, I'm not really sure. So if we think about the case statement, how much have we covered thus far? Honestly, we've covered about half of it, right? If you think about what we did, and we think about that third of a page, third of a page, third of a page, we just wrote a page of your case statement. Right? If you can get through all that piece we just did, which again, I think even just talking to some of the teams here, right, it's a non-trivial thing to go through, right? If you really, really ask yourself, who's going to use this thing? And do I understand what they do today? And do I understand how now it's going to make their experience different? It's not as easy as it looks. So, we've gone through how do you sort of do the research, get a macro problem statement, solution overview. A solution overview really just is saying, I'm going to solve this macro problem, right? It doesn't have to get into the nitty gritty of how I'm going to solve it, et cetera. It just sort of says, I'm going to solve it. I'm going to try and use these elements of Watson technology. It's very high level, right? And then what we did was we got down into the bow tie and we drilled into the micro problem statement. So now what we're going to talk about is, okay, I get it. You're going to solve world hunger. And then you told me more about this specific instance of world hunger that you think is really indicative of the broader trend. Now we're going to keep on that really, really indicative example, right? And we're going to try and solution that in a little more detail. And then what we'll see is we'll stay down in the bow tie and we're going to try and create the value, right? By remaining focused on something specific, because it's really hard to think about a macro problem and say, oh, I'm going to cause this much help in the world. But if you know that a social worker, right, spends X amount of hours doing this task, and you can make an assumption that you can eliminate 20% of it, well, then it might be easier to get what is the benefit to one social worker. And then how many social workers are there in New York? Blow that up. How many social workers are there in Austin? How many social workers are there in Los Angeles? How many social workers are there in Madrid, right? But you start with that very specific piece, again, all the way through the business solution, and only at the end you actually come back out into the bow tie, right? So how do you prove that you can solve the problem? The answer is not Watson. Really simple. That's probably the biggest issue we see with some of these early case statements. And I think there's going to be a bit of that in your initial case statement solely because you haven't gone through bootcamp number one yet, right? You haven't really learned in detail how Watson works. There's a lot of information out there on YouTube. You can go onto the IBM Cloud and look up how all the services work, et cetera. Really good detailed explanations. I assure you, you can self-teach. There's also an element of time here. Totally understand that. You guys don't have unlimited time to go and read about this stuff. But as you go through this competition, you're going to want to get more and more specific and more away from Watson's going to solve this, right? Watson is not a panacea. Watson cannot do everything. Watson cannot solve world hunger, right? But what it can do is it can, down in that bow tie, for the right type of problem, solve a very specific piece of an individual's workflow, right? And if you've picked the right workflow, if you've gone down the bow tie correctly, and you solve that little choke point, then you can come back out of the bow tie and you can actually make a big amount of change, right? So, again, focus small on this piece. We're going to be living in this sort of centerpiece. And then the first thing you're going to do as you sort of think about how do I come up with a solution is don't start by looking at all our technology and seeing what our technology can do. It's okay if you want to go and just kind of look at, all right, they've got some things that have to do with natural language and some things to do with emotion and sentiment and vision, right? And it's okay to think about, okay, what are all the data streams that are out there and that are potentially able to come into this solution? There's social media, there's all the New York City data that's available via APIs that I think they covered in the intro session. I can't remember what that is. Data.not.New York City or something like that. I think that's up on. But the first piece of all of this is about defining the capability that's needed. Okay, so remember when we did the if-only statement? If only I could do this, right, then my problems would be solved. Now you're sort of pretending like you're the technology and you're doing the same thing for the technology, right? What is it that the technology needs to be able to do to solve this problem? Not what does the technology do, right? So start with the problem and think about what is it that you would actually need to be able to achieve with the technology. Now, if you're an engineer or a CIS major, right, you could literally get this down into a series of functions and how do those functions interrelate, right? If you're not, that's okay. I think it's easy enough to say things like, this is going to need to be able to extract key pieces of information out of a big, long narrative form, right? So let's go through 2 examples here and sort of the logic they went through. So Watson LMSW. So what did they understand? So the first thing they had to understand was, all right, so this data is out there somewhere. We know we want to sort of solve this organization problem. What does this data look like, right? If this data was in some sort of structured database already, it would be a very different problem than if it was just in these raw text narrative fields of caseworkers making their notes. Sometimes actually handwritten, but oftentimes typed into a system. But it's basically a Word document, right, or a text document saved into a file system, right? And that's what they figured out, was all of that was stored in kind of plain text documents, right? And they found out in New York City, the information is currently stored in a system called Connections. They were able to find all sorts of, it's a public entity, so they were able to find all sorts of budget information about the hundreds of millions of dollars that had been spent on Connections, the inefficiencies it had actually created, because now there were 2 copies of everything. There was the paper copy and the electronic copy. It was all still pure narrative, so people still had to read it. Half the social workers were just going and printing out everything from Connections anyways, right, which was causing more paper waste and more paper usage than the paper files had. And so they thought it was a pretty big issue. And so, Connections was helping to centralize the information, but discovering issues still required foraging, right? It still required going out and trying to discover different elements of things. And so to them, what they said was, well, how do I do this more efficiently? They basically drew the comparison to Google. What has Google done? They took a bunch of raw text across the web, right, and they indexed it, right? They made it searchable by tagging key pieces of it, right? What are the keywords in here? How do those keywords relate, right? And Google's evolved over time to get much more sophisticated, but how do we link all those things, right? What they said was, okay, we need a capability that almost is like my own private Google for this set of information that's looking very specifically for things relevant to social work. And we're going to define this sort of type system of key entities and concepts that need to be extracted, and then sort of organize the information that way so they can be presented much more easily. And then the foraging and discovery, right, is much more accessible for that social worker, right? And so they needed that capability. How do I read across those documents and extract key information, right? Now there's the whole UI component of this and what was it going to look like, and I think that's what you define in technology as you actually continue to work with your end users, and it becomes a very detailed design process. But just at a macro level, they were able to say, okay, we need something that can read across documents and extract key information, and they had this vision of a dashboard, right? Okay, by reading this document, I know it goes in this piece of the dashboard, right? It needs to be accessed this way. And then I'm gonna extract numbers out of some of these, right? And that's gonna help me form a trend line, right? And then I'm gonna be able to come in and see this dashboard, and if I need to find the raw file, find the raw narrative, I can click in and find it. But then I'll have this trend line, right? I'll be able to see these key values like risk assessment scores on a scale of 1 to 10, right? How can I extract that out and then track that over time? For Watson DCS, so this was a little more, you can tell just even the way I wrote it, I tried to indicate, again, this is the little more technical team. What they learned was basically disease testing information comes into New York Health and Human Services XML file, which is just it's a fancy way of saying a flat text file with a bunch of different lines. It can easily be converted into an Excel file, just line after line after line after line, right? So they also found out that, yet again, there was a system already trying to solve this, right? So another thing I'd say is, think about who's the end user who's trying to solve this problem today. Also think about, is there technology they're already using to try and solve this? What are technologies? Connections was a big custom thing. This classifier they use today, big custom thing. What's another technology they might be trying to use to solve it? Google. Dropbox. These are all enabling technologies, right? But Dropbox may not be the best way to organize files for something like social work, right? We've all been in a Dropbox file that starts to get kind of messy, and right? So you probably need a little more sanitation around that. So then they saw, okay, well, even within this, the classifications they get today are less than 50% accurate, which means because the accuracy is so low that a human, they run it through the classifier every time. But a human actually comes in and checks 100% of those, right? Now, for those of you guys with a little more background on machine learning, I'm just going to do a quick aside here. This was a really interesting find for these guys because what they saw was ground truth. This is training data, so some of you try and keep this in mind as you go to boot camp. Humans were labeling hundreds and thousands of examples of this stuff accurately. So you had inputs and you had human labeled outputs. That's how you train machine learning algorithms. Having a human labeled test set like that is very, very valuable. And that's why these guys were able to build a working prototype. If they'd never stumbled upon that, they still could have defined a really good solution, but they probably never would have been able to prove what they did, which was classifying to 97% accuracy, not 50% accuracy. But what was the capability they realized they needed? In this case, plain line of text, plain narrative, short, sort of like a phrase or a sentence. Need the capability to classify text strings, right? Again, just trying to use more technical language here, but into predefined categories, diseases, right? So I had a bunch of buckets of categories and a bunch of text lines coming in, and I go, well, this one goes in that bucket, and this one goes in that bucket, this one goes in that bucket, right? Nothing I've said thus far says anything about a technology and what its capabilities are. This is all about what capabilities would I need to solve this, right? And then you can start to ask yourself the question, honestly, does this make sense? And if it doesn't, remember, it's okay to walk away from a project. We'll talk about that more at the end, but it's totally okay to say, okay, we've hit a bit of a dead end here. Where else can we go? And if you get really deep into the weeds of this competition and you really hit a dead end, call me. We'll talk about it. You're never irrecoverable. So then what did both these teams do? Then what both these teams did, once they said what are the capability they needed to solve the problem they wanted to solve, then they went out and looked at what capability was out there. So if you follow this link, right, this will take you to the Bluemix catalog or the IBM Cloud catalog. The tail end here just gets you down to the Watson piece, but you can just scroll down to that or click down to that pretty easily. These are the capabilities that we offer today. You guys are going to go through all sorts of workshops on this at Bootcamp number 1. But again, it's all publicly available. If you click into this, you can get more detailed descriptions of what all these things are. But they went out and they started to look. And you know, one group sort of looked at, well, discovery, a cognitive search engine. That reminds me of that Google thing. I'm trying to build an internal Google. And then natural language understanding, analyze text, extract metadata, such as concepts. Interesting. And then the other group, what did they do? What was their issue again? They needed to classify text, right? Text strings, natural language classifier, right? They were able to sort of get to, oh, natural language classifier performs, right? So out of that, that's how they kind of came to the capability they needed, right? So LMSW, a capability is needed to read across documents and extract key information, right? That's what we said. This is the exact text if you click into natural language understanding on Watson. Analyze text to extract metadata from content, such as concepts, entities, keywords, categories, sentiment, emotion, relations, and semantic roles, right? They went, okay, we think this is probably plausible, right? And so the other piece of this, I just want to sort of remind you guys, is we're looking for plausible here, right? As you look at all the APIs that are there and as you're reading through them, as you're going through, if something doesn't exactly fit to what it is you think you want to achieve, I think that's okay, all right? And the other thing I'll tell you is this is a Watson-sponsored competition. We really encourage you guys to use Watson technology, and we're making it all available to you for free. We're also huge believers in the open source community of artificial intelligence. So if you want to go out there and you see other capability that another platform has, or you read some cool science article about what can be done with machine learning and that capability's out there, by all means. If you build a working prototype and one piece is Watson and another piece uses something from algorithmia.com, some open source, API, cool. Totally a fan of it. But what you have to ask yourself is, do you really think this is plausible? And just be honest with yourself, right? Because at the end of the day, the judges are going to be, maybe not me, but people who are a little more familiar with the cognitive technology, et cetera, right? And they're going to be able to sort of look at things and say, yeah, this does or doesn't make sense. So if you're not honest with yourself about whether or not it seems, again, plausible, not possible, plausible, maybe you want to sort of back up and sort of iterate a few more times or try and sometimes just coming at the same problem from a different angle, right? So then these guys, same thing. A capability is needed to classify text strings into predefined categories or diseases. Natural language classifier. So the natural language classifier service applies cognitive computing techniques to return the best matching classes for a sentence or phrase. You can see pretty close matches, right, to what you need. So there's a lot out there, is all I'm saying here. This is a really scary part of the competition for some people. I totally understand that. I wouldn't get too hung up on it. Some of the tricks I've encouraged teams to use in the past. Could you do it if there were 1 million of you, right? So natural language classification, great example. This guy's spending 3.5 hours manually classifying this today, right? Let's say he has 10,000 examples and he does 1 a second. If there were 10,000 of him, how long would it take him to do 10,000 examples? 1 second. It's about the same time a computer would take to do it. Well, when we talk about AI and computer intelligence, right, could a human do it if there were 10,000 of them? And then also just think about like simple human processes, right? If we think about the state of AI where it is today, complex synthesis of ideas and what it takes to write that really hard, freshman year English paper, things like that, probably not doable with AI today. But classifying rows of text, things that feel monotonous, classifying images, saying that's a blue shirt and that's a gray shirt, but thousands and thousands of times with machine sort of accuracy, those are the sorts of things we're starting to do today. So, just kind of encourage you guys to explore the capability that's out there, both with Watson and again, in the broader community. There's a lot. What I love about technology is a very open field. A lot of people publish what it is their technology does, right? And try and match capability out there. But start by defining the capability that's needed, right? So then the last piece of this is to think about, okay, how then does this workflow change, right? In theory, we've done our background research, we've talked to our users, or we've read their job descriptions, we've come up with some imagination of what their workflow looks like today. The thing you then want to sort of double check down on is, have I actually evolved what their workflow is going to look like, right? So let's take the 2 examples. So Watson LMSW. What did it look like before? And this is very rough and high level, and honestly, I didn't do all this user research, so if the girls or the guys were here, they could explain their projects way better. But before, a new case was introduced to a new caseworker, right? Maybe it's an old case, new caseworker. The caseworker quickly scans a file. Sounds easy. We talked about it's thousands of files, right? A decision is made. Frankly, right, they remove someone from their home, they place them into the foster system, they release them back into their home, they're bringing them in protective custody, whatever it may be, right? Another event occurs and they get called back out there again. Oh wait, not the same caseworker. Now they're doing the foraging again, right? Now they don't have that history, right? That was the problem we were trying to solve. We were trying to make it easier when that new caseworker gets pulled in to analyze everything that's happened historically, show that time and that chronology, right, and find that. So what's it going to look like now? A new caseworker is introduced. A caseworker is given a file summary, right? They're not just given the files, they're given a summary. And they can drill in where they need to, use their intuition. They're going to have to get more detailed on certain things, but they're given a summary, right? Then a decision and an action plan. Part of their mission was, okay, how do I create an action plan? How do I then say, okay, this is what the next step is going to look like, so that when that next caseworker gets it, they can look back and say, well, was that action plan achieved? Was that thing we were monitored for, right? And that's going to slot into a very specific piece of the system, so it's at the forefront, right? So we can check in. There's some consistency, right? Another event or checkpoint occurs. Explanations for past decisions are accessible, right? So high level, but 2 things here. I think these are the 2 steps, right? Building the action plan and providing the summary where the cognitive technology was used. The workflow is still more or less the same, but the way the end user, the social worker, is interacting with the information and then making the decision is different, right? They're now interacting with the piece of technology that's making their lives and the lives of that other caseworker who's going to pick this up later easier. Other thing I'd point out here was their vision, quite honestly. They weren't the most technical team, and so they weren't really able to architecturally define this, but it was Watson and other technology. It couldn't just be achieved with Watson. Watson alone wasn't going to solve those two pieces. But the sort of technology we're talking about was very traditional databases and analytics, and so it was still very plausible, right? And they could conceive of that. DCS, so what happens today? A new batch of test results comes in. The results are auto-classified with 50% accuracy. A researcher corrects the results to about 95% accuracy, is what they put their own human error rate at. Then the analysis is actually conducted to see if there's an outbreak. Right? Only then. Then maybe some emergency action is taken, maybe, right? What happens after? First, notice, whole step of the process is going to go away. It's different, right? Same process, better enabled. Different process, right? Either's fine. New batch of test results comes in. Results are auto-classified with 97% accuracy. They felt if the human corrections only get them to 95% accuracy, and we can get to 97% accuracy, not clear to us that you actually would need the human in the loop at that point, right? Maybe they do some light checking. I think instead of 3.5 hours of time being eliminated, they said they would leave a half hour in, so they took 3 hours out of the workflow when they got to the business case. But analysis is conducted on a batch of results, right? So we skip this whole correction. Analysis is conducted, emergency action, taken or not taken, right? So that's how you then kind of connect it all back, right? If you can think about what capability would I need, is it plausible that that capability could exist? And then, am I actually solving the problem, right? What does the workflow look like before and after? You can't have a workflow, by the way, without a user. This would be very hard to do for your example earlier because you haven't quite figured out who that user is. But once you do, it's going to be really easy. I guarantee it. Because you know what problem you want to solve. But you got to sort of figure out who solves it, how do they solve it today. Then you've already figured out how you're going to use the Watson piece of it. So then you just have to think about what would it look like tomorrow, right? Cool. So what's the output here? So I talked about two totally different teams, and I think these weren't in until a later stage of the competition. But I just wanted to give you guys a sense of where these teams ended up. So we talked about Watson LMSW. They had this vision of this great dashboard, right? And Nancy comes in, and she's the social worker, and this is John Doe, her case, and here are some of her other cases. We talked about this timeline, right, of extracting that numerical thing and then sort of plotting a graph over time. They wanted to be able to summarize information. You guys know what lorem ipsum is, right? Like a lot of this text is lorem ipsum, okay? They just wanted to be able to show and conceptualize what this might look like, right? But it was a very useful mechanism for them. Not a requirement by any means. I think all of this can be explained via a very concise, very pure narrative. But it's something they sort of chose to do because they had that skill set. And I think it helped bring it to life, honestly. So when they created this as part of their video, which I believe is milestone number 2 of the competition, along with the business case, right? So that's sort of them, where they ended up. And then these guys. So here, I finally have one of these. I can't even read it. Maybe I can read it on my screen. What does it say? Ampicillin, sus, null, bacteria, still, culture, null. Really hard to read, even for a human. Turns out that our natural language classifier is able to tokenize that and classify it really well. Again, there's an element of these guys actually having a working solution that was a little lucky, but there's a lot of skill involved, right? They identified that really specific thing. They found this really good data set, and then they tested it, and it happened to work, right? That's just science. That's computer science at the end of the day, right? But the art of what they did, why they won the competition, was because they were able to identify such a specific choke point that had so much potential, right? All I have to do is classify these things accurately, and I solve this massive problem for this massive city agency, right? That's the art of this, right? That's the art of the bow tie. So this is a screenshot of their working demo. As you can see, not nearly as sexy as this from a visual perspective, but the fact that 97% of the time that was right, pretty sexy. That's sort of what they got to through this piece of the process. So same thing, I'll sort of stop here for a bit. I think if you guys could just spend a bit of time, and I'll come around the room again, try and talk to some different groups this time, but I would encourage you to then sort of think through, if you're still sort of making it through the process, it's okay to revisit the past questions as well, or just brainstorm, whatever you want to do. What is the capability needed? Not what can Watson do, what is the capability needed to solve the discrete problem you've defined? And then what Watson services or other technologies might be helpful in solving that problem. So some of you have laptops open, you're encouraged to go up on Bluemix, etc. I'll throw those up for you guys as well so you can sort of brainstorm, and then I'll kind of come around the room for a couple minutes. Just give me a second, I'll be right back, all right? Cool.
Because we needed to analyze how to measure and then also we can show I'm not sure about the first.
All right. So we're gonna get going here just because I don't want to keep people too long after noon. Guys, can we circle back here quickly? So I know there's a lot of sort of conversation happening, which I love. I do want to get through the last piece of this because I think it's one of the trickiest pieces to it. Sort of after this, just sort of talking around the room. Things that sort of came up. One thing that came up was some people have been able to go through an example really well of like a who, what, wow statement. Okay, what is the capability that I would need? And then they've made an initial guess at sort of what capability they would use. But when we sat back about it and we thought, well, one, is the problem we're solving really addressing either a New York City or higher education prompts? We weren't sure that that was true. And then two, was the problem they were solving really big enough to kind of capture that first big part of the bow tie, right? They'd started out almost too small, right? And so, another thing I'd encourage you is you don't have to just go through this process once. You can get through this process, initial iteration, 5, 10, 20 times on 20 different ideas, right? And then you can sort of think about, well, what are the merits of each one? And you can even enter the boot camp with 2 or 3 in your back pocket, right? And if you only have one until the boot camp, and then you come with a new idea there and you throw that one away, I think Dr. Altman talked to all of you, totally okay, right? 1 million iterations. The initial case statement's not going to matter. I think the initial case statement is about an initial pass through of this. Try and stay within the guardrails of the competition with that initial case statement, I'd say is the only real limitation. But it's an initial draft. It's initial time going through this exercise. So also got a question offline here. So does AI integrate with other data sources like Facebook and Instagram? So it's a great question. So in terms of the AI and the data sources, and thinking, I think this question really ends up being about plausibility again, right? I talked about there's our AI stack, right? And then there is all the other AI stacks and the open source, et cetera, that's out there. I think the best way to think about this is more or less that it's the same from a data perspective. There's the IBM data sources. We have a Twitter API, for example, that gives you certain access to Twitter data, et cetera, that is available to you through the Watson platform as part of this competition, I believe, right? A certain amount of tweets you'll be able to pull for free. There's public data. A lot of information on Twitter is actually public. You can scrape the web. You can scrape Reddit. There are all sorts of public data feeds like that. There's the New York City data feed, right, that's out there, right? All these things are free. Then there's paid data feeds. So Facebook, they mentioned specifically Instagram. Facebook has Graph API, or did they change the name of it? They might have changed the name of it. But that's how all these different applications, when you log in with Facebook, right, and then they know who your connections are, so you don't end up on Tinder dating your best friend, whatever, right? That's how that actually works. That's paid data, right? So you can look around what's available but paid. But the biggest thing about plausibility from a data standpoint, or I guess two big things. One is, does it exist at all, right? If no one is collecting that data in some form today, right? Remember my example with the camera on the head and the person walking in and seeing whether or not there were signs of mistreatment? Those video feeds don't exist today, right? And so there's no data to train machine learning algorithms on for something like that today, not to mention the awkwardness of then insisting people have to put a camera on their head to then get the data coming in tomorrow, right? So that data doesn't exist today. And then the second is, even if the data does exist, could you get at it? Or is there some sort of privacy restriction in getting at it, right? If your solution requires you to know the browsing history of every individual on the planet, the scary thing is Google actually probably knows a lot of that, right? If you use your Chrome browser, that's not your data, it's theirs. But would you be able to get at it? Or is there some sort of privacy restriction around that? And I think more or less the answer is there's a privacy restriction, right? And so there's an ethical concern there. There's also a reality concern. For example, the big banks aren't just going to hand over to you everyone's transaction data. You need to be sort of a trusted party to be trusted with that transaction data. And so that can be a bit of a barrier as well. So data is as important as the technology that consumes that data in terms of thinking about plausibility. It is sort of how I'd answer the question overall. Make sense? Cool. So just sort of checking back in. We did all of this in the first piece, and then we spent a bunch of time just on that one piece. And I think that's okay, because this is a really hard piece of this. But where we'll sort of go next is, all right, staying within that centerpiece of the bow tie, what's the value that's created? And then we'll also talk about, then how do I balloon that value back up to the big picture again? So if you remember to the beginning of this presentation, we talked about this as why should I care, right? And I talked about there are a couple reasons people should care. Only one of them is money. I think you will find that in a lot of public institutions and in businesses, money talks, and it's a really good way to get people to adopt technology. It doesn't mean it's the only way. And at least my opinion is if you build a really compelling case statement that's not going to save the city a dime, but it's in terms of directly trackable costs, but it's going to have this really, really positive impact somehow, I think that's okay. I would encourage you to think about what is the way you can sort of track somehow to some sort of financial outcome. But two other areas, so time. I think you'll find a lot of instances time is money, right? Whether it's repurposing how people use their time, like the disease classification guys, repurposing how certain workers are used, things like that. And then there's an element of altruism as well, right? Does it just make people feel good? If you think about our two examples, I would actually say that both of these examples had all three of these elements, right? And you'll see as we go through their business cases, they both ended up here and they majored here because they sort of felt this was a business case competition. A lot of the judges were coming in from big consulting firms like Boston Consulting Group, and they sort of figured this was where they needed to end up. But if you think about the start of the bow tie, they kind of started here, right? And if they hadn't had this component, would people have liked their solution? The dollars relative to the New York City budget that you'll see in their cases are relatively small. They did have some savings, which justifies it, again, from a business case perspective. But what might actually make someone do it was probably this piece. And then the way they got to the money was ultimately through the time piece. So again, sort of going back to the bow tie, this is going to be largely majoring on the small, right? When you try and define the value, it's really important to still stay small. Because if you start to think about the problem very holistically and hundreds of millions of dollars are spent on this and I'm going to eliminate 5% of that and so I'm going to save the world, $50 million. Fine. But if you can back out of the other way and say, for each individual, I understand that 8 hours of their day is spent like this. And this is the 1 hour that I'm going to eliminate 50% of the time on. So I'm going to get rid of half the hours, and there are 1,000 of those people, and each of those hours costs this, and this is how those hours are used. And so I'm going to repurpose the hours to do this, and the benefit for that is this per person. And then there are this many people in this city, and then in all the others. Then you sort of bring it up, and you show how it becomes a very big number, starting with something small that gives you some credibility and that you actually understand. That's how a good, compelling business case typically sounds, right? If you you guys have taken just sort of basic chemistry, usually these are big, long stoichiometry equations where at the beginning you're dealing with people and hours, and then at the end you're kind of converting to populations. All right, so first question we sort of want to go through here. How many of you guys are familiar with a key performance indicator? Has anyone ever heard that term before? Yeah, I had never heard of a key performance indicator until my junior year internship in college, but super popular business term, sort of self-explanatory, often referred to as a KPI. But what a key performance indicator is about is it's all about measurement, right? A business or an organization is going to do a thing, implement a technology, change a process, whatever it is. In this case, let's say it's implement a piece of Watson or AI technology. How are we going to track whether or not that's actually doing what we intended for it to do, right? So I had this problem I defined, then I'm going to implement this technology. The first question is you sort of try and get to a business case that you have to ask yourself is, okay, well, how would I track the outcome of that thing, right? How would I try and determine that, yes, this is in fact doing what it's doing? So let's take LMSW again. If I give social workers the support they need, I'll know because I'll see, and you guys have seen these dot dots. I love these sorts of statements. If you're ever kind of stuck on some of these problems, go back to this presentation, it'll all be online. Just write this out, literally handwrite it. Just write, I'll know because I will see, and then just let your mind wander. Don't stop writing. If you have to write until an idea comes to your head, that's fine. Just write it out, and you'll be surprised how quickly you can kind of get down to this stuff. But KPIs here, so fewer incidents of maltreatment, right? That's trackable. We know that because, remember their background research, it said how many incidents of mistreatment, so it's clearly trackable. More consistent outcomes for children in the system, right? Probably trackable. Might be a little harder, but probably trackable. This was really interesting. They went, okay, well, what happens in cases of maltreatment or inconsistent outcomes where the city doesn't do its job properly? How does that impact the city? They ended up building their business case around this piece. Less money spent on legal settlements, but they used the first two KPIs to show how they could improve the amount of money being spent on legal settlements, right? DCS. If I minimize manual classification for researchers, I will know because I will see less time spent on classification tasks. Really obvious. People were able to qualitatively tell them it was about 3.5 out of the 8 hours of their day spent on those tasks, right? I'm sure if you reduced it as much as they probably did, that's a lot more. More time spent on analysis tasks. Really, those are just the inverse of each other, right? And then here's where their moneymaker actually came. We'll talk about this in a second. You could, in theory, not do this, spend less time on classification tasks, have less researchers, lower your costs. But depending on how the costs work out, if I have a faster response time on disease outbreaks, could I save more money responding to disease outbreaks faster than I could if I actually eliminated the people whose time I, in theory, eliminated out of the system? And so you'll see, in their case, you're going to see a very sort of straight calculation of how we're going to try and reduce legal settlements, and we're going to make some assumptions around that and back into a business case. And in their case, they actually sort of had to weigh two sides of the coin. And they said, well, we can save money this way or we can save money this way. Which one could potentially have a bigger impact? So then you have to sort of walk through in your head, how do these KPIs translate into dollars and cents, right? And I say dollars and cents here, again, I think it's okay to have a really solid altruistic goal or really solid time savings associated with your case. I would say if you're a competitive person, from a competitive perspective, the types of judges we have in this competition tend to look for some element of a financial case. I'd also say based on the number of business majors in this room, this is a worthwhile exercise just to flex those muscles. Because I think no matter what field you go into, whether it's raw science, writing grant proposals, et cetera, you're going to want to be able to sort of be comfortable working with these sorts of numbers. So LMSW, what did they do? And again, both of these guys were on both pieces. But so today, for every 100 incidents, and by the way, these figures are not exactly what you'll see in their case statements, just because I wanted to simplify this a little bit for this. This math can be multi-step math. It's not overly complex math. It's usually just basic arithmetic. But these are some simple examples. So what we said was, okay, today for every 100 incidents, there are 2 settlements. That may be available to you in your use case. It may not. If it's not, someone asked a question earlier, what should I do? Make an assumption. Make the best assumption you can possibly make. Be very clear that you're making an assumption, and then move on. Okay, there is no solution to the fact that you don't work in this department or that you don't have access to this budget. What you will find is that city agencies, there's a lot of information about their budgets out there. But it's okay to make assumptions. Just try and be rational about that assumption. Don't assume that someone's getting paid $7,000 an hour if they work for the city government. It's pretty unlikely. So 100 incidents, there are 2 settlements. Settlements on average cost $1 million. Last year there were 1,000 incidents, right? So 1,000 over 100 times 2 times $1 million. They're spending something like $20 million a year, right, on settlements, right? Everyone gets the math more or less, right? Pretty straightforward. So then we say, all right, they're spending $20 million a year. If we can reduce incidents of maltreatment by 10%, that eliminates 100 incidents per year, right? So reduce incidents of maltreatment, KPI, right? If we improve consistency by 10%, we can lower the average settlement cost by 5% or $50,000. So then my equation changes. Now it's 900, there's 100 incidents less, over 100 times 2 times 950, 50,000 less, 17 million a year, total savings 3 million a year. Something like that, right? So this is a really interesting example of how they did this, because what drives this number is legal settlements. That's the KPI, right? Ultimately, is how many dollars am I spending on legal settlements? That's how they got there. But the way they were able to sort of think through, okay, how would I actually do this? Well, if there are fewer incidents of maltreatment, then there are less times we get sued, effectively, right? And if there's more consistency, we think we're going to be able to argue for lower settlements, right? What causes these issues, right, is that there's so much inconsistency in the system that someone makes a really bad error and it costs the city a lot of money. But if there are less really bad errors and they're just smaller errors or there are fewer errors, right, then I'm going to be able to sort of condense those costs. And again, the driver they ended up really gripping onto here was legal settlements. Now, you may find in your business case that it's more than just legal settlements. You may have, I think they actually did have 2 or 3 different elements of cost savings. But the one I really liked as I was reviewing these cases again last night was legal settlements, because it really shows, everyone sees that, right? Sort of those 3 KPIs and how they come together. Less incidents, less variance, all of that brings less in terms of legal settlements, which those KPIs, all trackable, can get us to some sort of dollar value, right? And then it's just a question of a cost today versus a cost yesterday, right? So that's a pretty straight line one. It's kind of interesting. And all of these are custom and all of them are different. This is something I encourage you to sort of work with your business mentors for. Certainly reach out to me if you need help. Again, I may not be able to help every single one of you, but I can probably point you to someone who can. So DCS took a very different approach. I talked about the trade-off they had, right? So today, let's say there are 100 employees. It's actually way more than that, which is the scary thing about this. It's thousands of employees doing this classification stuff. There are 100 employees spending 8 hours per case, so we're just assuming sort of 1 work day per case. 3.5 hours, we've been saying that number all day, spent on manual classification, right? Employees make about $20 an hour. These are very skilled employees, right? And that's cost, right? But missed cases can cost the city up to $100 million a year. So that starts to be a problem, right? Okay, so maybe I can reduce employees, and I'm paying those employees hourly, and so I could eliminate costs out of the system that way. There's a business justification. But if I do that, and I still have the same amount of accuracy, and I'm spending hundreds of millions of dollars per year because of these missed cases and these missed outbreaks, maybe what I need to do is point all those really talented people at the analysis part, not the classification part, which is really what they should be getting paid to do, right? And maybe I can save millions, hundreds of millions, right? Now, when this team actually presented their case, they focused a lot on this $20 per hour when they were doing sort of the business case piece of their presentation, because it was clearer to lay out, because there were KPIs that got them there, because it's just hours spent on classification tasks, right? There was a direct linkage, and they wanted to show that no matter what, you're going to be able to save enough money that this is worth doing. But when you heard them present, this is what they were all about, the 100 million, right? So this was interesting because it was almost like they showed the time and the money, right, that were very obvious, and they said, look, you're going to save money if you do this. There's always going to be a way to save money if you do this, so you should do this. But eliminating those employees may not be your best choice, because there's something that's going to make everyone feel a lot safer and a lot better about this if we can do it. And I may not be able to perfectly KPI sort of link it there, but I can show enough figures and enough stats out there that sort of say, you know, no, this could be something very, very valuable. So again, if 3 hours of classification time could be removed, one could either reduce headcount, so 3 hours out of 8 hours times 100 times 20 times 2080, so 2080 is about work week or work hours in a year, 1.6 million. Or, you know, you could just say something really high level, right? Contain 10% more outbreaks, 100 million times 0.1, 10 million. If this is all you do for your business case, I think what you'll find is people will sort of look at you and go, you haven't really thought through this, right? You haven't gone through that process of understanding the problem, figuring out what the KPIs are, how are you going to measure it, how are you going to see that return? But I would encourage you, in a case like this where it's actually kind of small dollars relative to over there, 70 million a year versus 1.6, which both of these are small numbers relative to the New York City budget. So that altruistic piece is really important, right? But $1.6 million a year, okay, this tells me you've thought through it. This shows me you've gained the skill of the competition. This shows me you've also gained another skill in this competition, right? Which is seeing the big picture, seeing what the potential could be, right? So we spent a long time in the middle of the bow tie. The next question sort of becomes, what's the macro potential of the solution? In both of these cases, they talked about it as a geographic expansion. I think that's going to be the case for the vast majority of you, because you're either going to be focused on higher education, probably thinking very centrally about CUNY just because you happen to be a student, or you're going to be thinking about government, but you're going to be thinking very much about New York City government because that's what the prompt is and that's where you live. But one of the things I would encourage you to think about, and what both of these teams really talked about, was, okay, how do I expand? How do I start with the red star in New York? And then thoughtfully, they demonstrated how would I expand. So first they'd go other places where English was a prevalent language, across the United States, England, Australia. Then as they had to expand into other languages, they would go sort of around the world. And what they did was they said, okay, if I know the savings are roughly $10 million in a city that has a population of 10 million, then it's sort of $1 per person, right? So then how many cities in the world could I implement this in? Over how much time, right? $1 per person based on the population of those cities. They were eventually able to show, here's how this still relatively big, $17 million in the case of LMSW savings, starts to get really, really big, right? Or in the case of DCS, here's how disease outbreaks around the world, you don't even have to put a number around this, people just get it. Here's how disease outbreaks around the world could be much better controlled. With this tiny, again, I love DCS because they had this little tiny piece, right? This little sliver, huge impact. Very, very well-trained engineers, I think. So then the other piece of this, and this isn't what either of these teams chose to do, is you can also think about domain expansion, right? So how can I go beyond just automating the disease classification? How can I start to automate the analysis piece of that, right? How can I automate then the emergency response that comes out of it, right? You can start to think about, what are those additional data sources? What are those additional capabilities that would need to come in, right? And then you can sort of expand from there. But I'd encourage you, sort of as you're thinking about your business case, focus in, go through the KPI process, kind of get there, and then think about at the very, very end, I think this is always the kicker, the best way to end a presentation is to bring it back holistically. So these are all in the case statements. I wouldn't focus too much on other people's numbers. You can see in this case, they actually listed out their KPIs in terms of cost savings from less training, litigation services, and then you can see the tort law settlements right there. Like I said, my numbers aren't the same as their numbers. They also looked at the current costs of this connections system, which is extraordinarily expensive, which they thought they could eliminate. But then they ended on Watson LMSW is poised to set the national. They didn't really think about it in a global sense as much in a national sense, but is poised to set the national standard for all statewide automated child welfare information systems throughout the U.S., right? That's direct lift from theirs. These guys, they went through their process. I think they were showing like $393,000 per year for this tiny little department in savings was actually the number they got to. So like I said, really small, but they really well thought through how they got to this number, which is really what it's about. Again, the process, because it could be that the assumptions they made, again, assumptions good, okay with assumptions, could have been way too low, So it's about the process, and the people who are reading these things, they're trained readers. They know, they'll be able to see that you understood the process, and that's what this whole competition is about. But then again, this is directly lifted from their video, and I think it was the last chart in their deck at the final presentation. These guys always had a global vision, right? That's what inspired them to do this project. I think their video at the end, it zooms out, it literally zooms out of New York City to the world, and then Watson DCS flashed on the screen, right? It was all about that global expansion piece, right? And it was all about combining small dollars, but potentially a huge impact, right? So we can spend another 5-10 minutes here. We only have about 5-10 minutes left, so I think let's actually just sort of skip this exercise, and there are just a couple more things I just kind of want to share with you guys before we sort of take off. So in terms of progress, I think we've covered each of these pieces. I really do. I think we've gone through more or less the skills you'll need. What I purposely didn't spend today's time on is how you should write it or what you should stylistically do. I think I said that earlier. I leave that very much to you. I'm sure you're all very talented, skilled university students and can sort of get through that piece of things, of how to explain these pieces. All I wanted to do today was sort of give you a toolkit for thinking about it, right? So think of this as more a series of exercises to put yourself through, a series of tests to put yourself through to try and do this. I do think this is a relatively good breakout in terms of the amount of page you could spend in a 2-page case statement. The other thing I'd reiterate, which I think Stan said earlier, is this is like draft 0.1, okay? You should be updating this thing constantly, always thinking about new things. And the other thing is you shouldn't be afraid to sort of step away from it, right? And just throw it all in the trash and look at something new. So parting thoughts, don't fear the bow tie. To some people, this process can sort of sound intimidating. To others, it doesn't, and then they get into it, and it's extraordinarily intimidating. If it doesn't feel intimidating or uncomfortable, because none of you have done a case competition before, and I think most of you haven't had full-time jobs of this nature before, you're probably not doing it right. It should take you out of your comfort zone a little bit. But don't be scared of that, because that's the whole point, right? Don't be scared of thinking big, but then spending a lot of time in here, and then checking back at the end, right? Can I still make that big statement at the end? But spend a lot of time in here, and don't lose track of this. That balance is non-trivial. Other thing, so this is the design thinking loop. You guys probably got introduced to this as well in the design thinking workshop, right? So this diagram I won't talk too much about, but it's all about iteration. It's all about coming back to this center point of reflection, right? So we start out, we go out and we observe, we do our research, we try and understand what the problem we're trying to solve is. Then we reflect on what could the problem potentially be. Then we make, right? We make a solution. Making a solution could just be a paper drawing. It could be a working prototype. Depends where you are in the project, right? then we make, and then we come back to reflect. And then we observe again, then we make, reflect. Maybe we make again, then we come back, right? But the key to all of this is each time you come back to that reflect piece, each time you iterate, be your strongest critic. Be the strongest critic of your team. You will have a much more resilient argument at the end of the day. Another piece of this I like to tell teams is, if you're asking the question of yourself of, oh, well, would there be a negative ethical implication of this? Think through, maybe there is, but maybe it's solvable. Make that a part of your case statement. Make that a part of your verbal presentation. Proactively address these questions. Show your audience, show your judges that you've already thought about the issues, because I guarantee if it came up to you, it's going to come up to the people in the audience, right? You've thought a lot more about this than they have. I think I've said this a few times today. Do you feel okay throwing ideas away? It is absolutely, absolutely, absolutely okay. I think they do an exercise in the design thinking workshop where they have you crumple up a sort of a sticky note as a representation of an idea and you just throw it down on the ground like that. Totally okay. Do not be afraid of doing this. If it's the night before final presentations, maybe that's a time to be a little more careful about it. But honestly, right up until 2-3 nights before the presentations, you can make some very, very big changes. The DCS guys last year, they came in and did a mock presentation to me. I think almost everything changed in the 3 days before they did their final presentation. Not the concept, the working technology, et cetera, but the way they presented, almost all of it changed. That whole scroll thing I talked about, I hadn't seen that until they did it. I think we chatted about the idea of it. I didn't think they'd actually do it. It was kind of cool, I guess. But yeah, anyways, throw ideas away. And then last thing I'll leave you guys with is, so I've been working in the artificial intelligence space 4 years now, about as long as the current hype cycle has sort of been going. I also have the good fortune of working with people who've been working in this space 20 years, so many, many years before the hype cycle sort of ever started going. But I think one of the most important things to just sort of remember and reflect on at the end of the day is that computers, and this is Thomas Watson Jr., by the way, this is the son of the founder of IBM, the second CEO of IBM, standing next to System 360, which was a very, very powerful computer back in its heyday of the 1960s. 60s? Is that about right? Yeah. Very, very powerful computer back then. Talking about this then, but still holds today, I think, which is you're never going to rob a man of his initiative. So don't sort of fear the AI. Don't sort of fear the consequences. Be very aware of them. Be very thoughtful about what it is you're doing. If you're talking about eliminating jobs, things like that, I think it's really important that you recognize what you're doing. But just sort of recognize that technology and all of this and the spirit of this competition, it's about evolving the way we do things, right? It's about evolving the way the city kind of operates or higher education operates. And so I'll just sort of leave you with that. So, thank you. Oh. All right, I'm going to do 2 questions here for the camera. I know some of you guys may have to leave, so.
It's actually 1 question.
Oh, it's 1 question. All right, so we're going to sort of think through this. Alan Chow, I was wondering what you think about a project on potholes. For example, creating something for reporting, using Watson for identification and repair optimization. Is this feasible given Watson's capabilities? So, couple questions here. Let's go through our process as we sort of think about it. Potholes. So who does that process today? How does that all work, right? Most, I think, pothole complaints are called in by one of 2 parties. They're called in via 311, so sort of good citizens calling in and thinking about, okay, there's a pothole here, I really want them to come fix it, and then it gets sent to the sort of department that repairs those potholes. Or it gets called in by a city agency. Another city agency, right? Department of Sanitation probably calls a lot of them in because they don't want their garbage trucks getting big flats and potholes because that costs them a lot of money. So they want another department to go use their budget to fix it so that they don't have to use their budget to keep repairing tires. That's the process that happens today, right? If you were going to put some sort of technology behind that, the first question you have to ask yourself is who is actually going to use that? Is there someone on the other end of that 311 system, et cetera, that's sort of processing those requests? maybe the user of your technology is not actually sort of the person who's processing the request. Maybe the app you're more focused on is the person taking pictures of potholes on 311 and then sort of sending those up. Well, then you sort of have to ask yourself, well, if I take a picture of a pothole, how many pictures of potholes are getting taken every day? Are there enough of them that I really need a computer to go out and identify that all those potholes are out there? Now, if there were enough, and I'm not saying there aren't, could it be feasible? Well, then you'd have to think about what's the capability I would need in that scenario, right? Now this person takes a picture of a pothole, it's automatically processed, and it gets given to the same person who takes the 311 complaints today. It says sort of pothole, not pothole, right? Well, so what would I need to do that? I would need a system that could help me classify a picture as a pothole or not a pothole. Looking at my system of capabilities up there, I think there's a visual classifier. I think if I look at that visual classifier and the description of it, it could pretty easily, with enough training examples, classify pothole, not pothole. So in that sense, is it plausible? Is it feasible? Yeah. So then what do I do? Okay, so it's plausible, feasible, there's a real problem there. Maybe there are just millions and millions of potholes. What is that actually costing the city today, right? Is it costing the city that they don't fix these potholes on time? Or if they fixed every pothole on time, would it actually run them bankrupt in a single year? Maybe there's a purposeful nature of the way they fix potholes. Maybe a lot of potholes get reported, but they actually wait till they're a certain size before they send a truck out there because they have to pay the guy who repairs that pothole a lot of money, you know, whatever dollars per hour, and they don't want to repair potholes till they're a certain size or they're going to create a certain size of risk, right? And so then you'd have to sort of think through that and say, okay, are there enough potholes? Maybe. Is there a capability that could help me solve that depending on how you frame the end user problem? Again, maybe. I don't want to give you any answers here. Sorry, Alan. And then is there a business case that justifies that? Again, maybe. I'll insert a little opinion here. I would say, Alan, I think you're probably focusing a little too narrow if you think about that problem. If you think about the bow tie, what you've done and what I just did sort of with you is you've probably gone through the exercise a little bit now, right? You've sort of found a problem, you've found an end user, you've figured out what their problem is. Maybe there are two end users. One is the person taking the picture, the other is consuming on the other end, and that can happen. You can end up with kind of two applications with two end users. It's important to usually focus on one is going to be the actual value creator. So you've gone through the exercise, you've gone through how that could tie to a business case. But if you really ask yourself, does that pothole problem blow back up into something that's really going to be big and transformational to the city? I won't answer that for you, but I'd think about that. I think you're probably sort of doing a really good job of thinking about the narrow piece and going through the exercise, but not unlike the group I was talking to earlier. You may want to try and go through 4, 5, 6 different ideas. Then it's almost like a 2x2 matrix, right? Think about plausibility versus potential for impact, right? And if you've got high plausibility but low potential for impact, maybe you don't go do that. What you want to look for is something that's highly plausible and has a huge amount of potential impact. So to answer your question really directly, do I think it's something that's plausible? Yes, absolutely. But just sort of revisit the process and think about whether that's where you want to focus. So, any other questions in the room right now? That public? I'm happy to stick around and answer questions like all day. So, not all day. I take that back, but for a bit. What's up?
I have a question. Openly, I mean, the project that I was thinking of was using to resolve the issue for CUNY itself. I felt when I was registering for classes, a lot of times, like if I commute, I have to like go to an app and figure out what classes are available. But linking those systems together, so what buses are running, what time I'm taking my classes, I can use that as one system where when the class is open, actually there's service out there that I can get to the class. And shortening my times to, for that day. Rather than spending time in school while I could be working, earning a living, and helping myself at the same time.
Yeah.
So that project, I was I don't know how AI was working with that, and is it a feasible thing that I can scale? That's
Yeah.
what
Yeah, well, I mean, go through the process again, right? Question one I'd ask yourself, because it's a really easy one for you, is go do your background research. There's a lot of people right outside or at the Baruch main campus there or at any of the city campuses that you can literally just go ask, did you have the same problem? If you want to formalize that a little bit, make a little survey, print a bunch out and get a bunch of people to fill it out. That'll tell you, do you have a real problem? That'll check that box. In terms of who uses it, I think you nailed that because you get it because you are one of them, which is always a useful place to start from, because if you really understand the pain point, then it's going to be a little easier. And then in terms of a solution, there's the data piece and the technology piece. We talked about both. I think you'd have to think about, are those bus routes and things like that available? I think you probably convince the school, if you had a really good system, to give you the registration data. I don't think that'd be that hard to get. But could you put that together? A question I would ask myself is, in putting those things together, it seems like you're looking at times and where do times overlap. That's sort of a scheduling issue. Do you really need AI or do you need a Watson to figure that out for you? Maybe. I don't know. And then at the end of the day, the other thing you'll have to figure out is the efficiency you talked about is to you, the student. So who's going to pay for building the system? And it may be that the university is willing to pay to build the system to help all the students out. But you may find that that's actually a bit of a rub, that the university has a lot of ways to invest in a lot of different projects that could help students out, and maybe they'd rather spend the money investing in better professors or retaining good professors than in building a system like that. So you'll have to think through that piece as well. So I don't want to answer your question super directly, just like I did with Alan, but I think the sort of we've seen similar use cases in the past. Almost everyone puts their own special flavor, so don't let that be any discouragement to you. But again, I just sort of try and go through that process again and see if you can check those boxes. Okay. So I think I'll stop there and then I can take the question in the corner because some people gotta take off. Okay? Anything else from you, Stan?
No, I think you've covered it all.
Cool. Alrighty. Thanks, guys.
Thank you.